Hey everybody, welcome to Logarithmic Equations Part 2. Now, I want to kick it off with this equation here that you see on the screen. Okay, this is really the motivation for why we're going to be looking at the equations we're looking at today. You know, earlier in this unit, we looked at exponential equations, right? And we said the goal is always to, get the same base on both sides so that we can just set those exponents equal to one another. Okay, well, we never considered what if that's not possible? What if we can't do that? Like here, right? I can't raise 2 to some power to equal 61. So what do? We never talked about it. How do we approach things like this? Okay, well, if we have problems like this, we're going to actually use logarithms to solve them for us. Okay, so let's talk about our steps and then we'll come back. Okay. So if we don't have a common base, if we can't find one, we are going to, first of all, isolate the exponential expression, make sure it's all by itself. And then we are going to take the log of both sides, right? Remember, as long as you're doing the same thing to both sides, it's fair game. So we're going to take the log of both sides. That's going to allow us to do something special here, and then we're going to be able to solve a logarithmic equation instead. So if I take the log of each side here, let's see what happens. Let's see why that's helpful, right? So let's say I do log of 2 to the x power and log of 61. So we're going to do base 10 because that's in our calculator, right? Now remember, we had a property for logarithms that said if there are exponents, they can be moved in front of the logarithm, which is going to make this actually solvable. So if I actually have log, or x times log of 2, I don't need the parentheses here, equal to log of 61. Okay, log of 2 is just some number, and log of 61 is, again, just some number that can be calculated. So to solve for x, I really just need to divide both sides by log 2, so it'll cancel out here. We divide this side by log 2. And then we can find a value for x. Now, it's not going to be exact. Okay, it's not going to be perfect. We will have to do some rounding. You're going to get decimals. Okay, but it's a very close approximation. It's really the best we can do. So if I do log of 61 divided by log of 2, I am going to find that x is approximately 5.93. Okay, I'm going to cut it off. We're just going to go out 2 decimal places. Okay. And there it is. Now we have to make sure that, if I plug that value in, I'm not going to create any issues like with my logarithms. Just make sure, plug it in, make sure it checks out, right? 2 to the 5.93 power is going to get you very close to 61. So let's look at some other examples here, okay? Let's look at one where we've got a little bit more going on. So here we have to actually isolate our exponential expression. Okay? Our exponential expression is just the 7 to the n power. So we need to get rid of the 4 that's in front just by dividing both sides by 4. So when we do that, we get 7 to the n power equal to 37. Now we're in this problem again or the situation again where we have the problem of not being able to get the same base on each side. Okay, I can't make 37, 7 raised to some power. I can't get a common base. So remember, our strategy here is to take the log of both sides. When I do that, I'm going to be able to move my exponent down, which is going to allow me to actually solve this equation. So now we have n times log of 7 equal to log of 37. And to solve for n, I just need to divide both sides by log 7. So now I can do my calculation, right? Type in log of 37 divided by log of 7 in your calculator, and you get n is approximately 1.86. Okay, and again, we can test it, right? If I want to plug 1.86 in for n, It's going to get us pretty close to 148. All right, last one for our video here. So again, we need to isolate our exponential expression here. The exponential expression in this case is 4 to the x plus 1 power. So not only do I need to get rid of that 7, but there's also that negative 1 that's really multiplied by. So let's subtract 7 first. Then divide by negative 1. Okay, and then we're going to take the log of both sides. So we said when we do that, that exponent, which is x plus 1 here, will drop in front and multiply our logarithm. So really what we have now is x plus 1, okay, I'm going to keep it in parentheses, times log 4 equal to log, I forgot my 4 here, equal to log of negative 11. So then, if I wanted to solve for x, I could divide both sides by log of 4. And then I need to subtract that 1 from both sides. So really, my calculation here, I'm just going to erase this, would be log of negative 7, or I can't read, log of negative 11 divided by log of 4 minus 1. Okay, that calculation would give me x. But you probably saw an issue probably about a minute ago. Okay, we've been saying we can't take the logs of negative numbers. So my calculation here to solve for x requires me to take the log of a negative. So what does that mean? Well, it means that I can't actually find this. It's undefined, which means my equation here, probably guessed it, has no solution. One of those special cases here so that you know what it looks like. Okay, we don't have a solution. Well, it's extraneous, right? We can't actually calculate it here. Okay, so there is no solution to our equation. All right, that is the end of our log equations part 2. Let me know if you have any questions, and have a great rest of your day.